Okay, my wonderful friends, this is Amazing Planet. This is Iceland, and it is the Littenfoss and Hegeflusk Amazing Planet, whatever that is, in Iceland. Now, it's a waterfalls, and it's a geographical anomaly by any means. Now watch what happens now. All right, look at this now. As you know, I understand these formations. And what you're looking at right there are tendon fibrils. That's an abrupt transition. These are tendon fibrils splaying off. So there's some form of a muscular architecture. And I have something right here that has a very similar situation to what you're going to see right there. Now, if you can see this is red, and we're going to see some very striking red features. Now, sometimes you can see a lot better once you put a little bit of moisture on things. Give it a second here. But when you have a lot of moisture in a continuous situation, it draws the transition metals out. And you'd see them if we could sit around here long enough and wait, and you may can see it now. But what you're looking at here is muscle fibers. All right, and there's a layer of actual blood. This is the skin tissue at the top. This is some form of flesh. And see, there's that red bloody layer. And this is all tissue, muscular tissue. And then there's another huge red bloody layer at the bottom. That's look at the size of that. I don't know what this was, but it was some very big, strong, muscular attachment. And on this side you can see, if you look carefully, there's a round attachment spot there. And then this little links from the bone to the muscle, and then the muscle runs off. And these are abrupt transitions out here. And you can see them in the microscope. You can see where it breaks and breaks and breaks. There's like 3 or 4 abrupt transitions. And they're just starting to understand this. They never could, you can't see these things in a living human being, or even when you do the autopsy on them. It's just not possible to see them. You have to see them in a mud fossil condition to get these structures to stand out the way they do. It's phenomenal, but it's true. So we're going to go back to this, and we're going to see exactly what this Icelandic waterfall geographic anomaly is. And I can tell you right now, it is biology. Now don't forget, I know these very well, and I have pictures of all this, and I have all the anatomical evidence to prove what I'm saying. You see these abrupt transitions? Abrupt transition? That just doesn't happen by accident. Abrupt transition. This is the glue that glues the tendons to muscle, and there would have been some kind of fleshy tissue up above, and that's how they glue in. The same thing with the one I just showed you a second ago. There's abrupt transitions in this, exactly identical. Identical. All right, I have to show you. All right, this is from the specimens in my shop. Remember I showed you those tendon fibrils and then the abrupt transition? They're identical. And after the abrupt transition, it goes into the muscle. And I'll show you that. This is that gooey stuff right above the abrupt transition, which had those fibers coming down. They come in hex, they come in squares, rectangles really. These are the same tendon fibers that make that pregnant lady stone. They're that big. They are just absolutely gigantic. And then in the center of that tendon fibril, there'll be some little vascular entries that'll give it some nutritional value. And that's what you see at the tip of the pregnant lady stone in Baalbek. And I'll come down here as I come down a little bit. And now you're going to see the muscle weave right into the glue. So you got your tendon, that little chunk, then you got your glue, then you got your muscle. This is, I find this so cool. Look at this. The muscle wraps right around in a circle into that glue. See it? You see it wrap right around in a circle? It wraps right around in a circle into the glue. So you had the tendon, you have the abrupt transition, glue, and then you have the muscle, and here comes the muscle out, and you'll see a couple of abrupt transitions. I'm showing the hook. And then there's an abrupt transition somewhere. I guess it's right about there. They're very quick, and then there's some mineralization into the muscle. I think there's an abrupt transition right there. And just after it glues. That's why you see them. That's where they fall off. And then there's another one up here. So there it is right there. That's the other one. This is some vascular network to feed it. And then there's another abrupt transition there. I'm telling you, I've studied these things extremely well, and I understand exactly what I'm talking about. I'm not guessing. Okay, Giant's Causeway over there in Iceland, they all have these hex fibers, even Devil's Tower. And they are tendons, they're tendons. And around these tendinous fibers is a synovial sheath. Every one of them has a slippery little, I don't know if there's a fascially they call it. It's a fascia around, and they all have to slide. And the amount of sliding is unbelievable. Synovial joints, which is basically this, is 4 times more slippery than Teflon on Teflon. All of that has to move inside of you without sticking to each other. And I worked with the autopsy people, and I understand this extremely well. And the people that are tight and can't move, are stiff, they say that when they do the autopsy, they can't move these fibers apart easily. Some of them just move right apart. Like he says, he slides his finger and it just opens up. Other ones, he has to actually use a scalpel to get in them. Now, again, and I have this in so many different ways here. What do we got here? This is about tendon fibers. On Mars, the same thing. See? On Mars, same stuff. Abrupt transition. Everything was, there's nothing that isn't. Look at this. These guys are crawling up these tendon fibers. I believe that is Devil's Tower. Here they are. This is exactly what it is. And they come down from big, heavy-duty tendons down to smaller and smaller and smaller until they get down to these tiny, tiny, tiny fibrils like I showed you before. And then when they harden up, they no longer are just little fibrils. They turn into crystal shapes. And that's the nature of biology. Now this is going to have an not abrupt transition. It's going to have like, I got something, okay, a bone like this. Now, you see this, that hole right there? There's normally going to be a ball and a socket, a ball in there, and then there's going to be another ball on the top. It almost looks like a barbell in the bottom, and then one on the top, and the ball on the top slams into this. Well, this thing is still here, and the stem is still there, and that's the ball above. And there's just some gigantic creature was here at one time and died there. What else we got here? There's tendon flotation. I don't know what that's all about. This is where they look similar. You see this? You think that's a giant tree trunk. It's not. That was a, well, here. You see what that was? It was just like this, only that is the part here, and then this is where the fibia sat here. The tibia is the big piece, and it goes here. And then you also have blood vessels here and there. And then you have them here too. I know what to look for. This is not tree rings. And this is broken off here just exactly the way this is here. And they all have, we have a tibia and a fibia too, only these are no toes. It's a whole new species. And I'm getting a whole batch of them coming in from Tish. And they have springs inside of them. Not like us. And everything, this is a goose. That's the feathers of a goose. That's a goose's head. The beak. All right, his neck. The neck, it turns to like basalt or, granite. It depends on what it's in. But they all have this coating on the outside, which is called fascia or tunica, or the geologists call it feldspar. It's the coating of all. It's really like interstitium, skin. It's the fabric of life that separates you from the rest of the world. And they all have it. Not a tree trunk. That was a foot. All right, so we're back to the Icelandic waterfalls, and don't forget now. I just showed you the abrupt transition is right there. That's what it is. It comes out and with the tendinous fibrils, and then they go here, and then you have that. Then the muscles wrapped right in. There might be even a little wrapping looking one here. This is doing the same thing. It comes up to the muscle, and then the muscle does the pulling. These don't have much stretch to them at all. These babies here, they're tough, and you can't pull them. The tendon holds the tension, and it's just barely gives. The muscle goes like this. They call them sarcomeres, and we'll see all that stuff. All right, I'm just going to play a little further here. Now it comes down through the waterfalls, and you can see abrupt transitions everywhere, everywhere, everywhere. This is fabulous, and I really appreciate being able to show this as a fair user, just to prove the things I'm saying. Now this is all biological. Now I don't know, you can see these little holes where water's coming out. That's some form of vascular network. And that's why this is too. All water coming everywhere, as far as I'm concerned, is formed originally from some vascular network. And then they turn into rivers and so forth. Wherever you see all this red stuff, that's growing out of the blood vessels that would have been there. And because this is a watery environment, they're being sucked up and they're feeding those. And this is all the same stuff, this tendinous stuff. Now, here we're going to get into some extremely interesting layering of well, first of all, whoops, what did I do? Let me get back out here. All right, where was I? Let's go here. All right, here we go. As we approach this, of course, we have the waterfall, and it's running all down here. We could see that we also have these banded formations, and then we see these colored stripes. What's that all about? Let's take a look. And you know that I have shown zillion times transition metals, especially red and black, are from blood. Now, this has a lot of, I don't know if this is enhanced or not, because the color of the water looks like it's somebody did some work to this, and it's really not this brilliant. But I can't say one way or the other. But I can tell you what I can say is that I can see these transitions, and what every one of these is some form of a membrane, or there's a bunch of different possibilities here. But it could be like a ripple effect from some type of a organ system that's, I forget what they call it, peristalsis or something, where it can push the food down, or in the female anatomy has that in the genitals area. There's a lot of things to consider here. But as far as intestines go, and the digestive system, the genital areas, they have a lot of interesting anatomy that it plays out in these stripes. Now, again, I think this is enhanced. I can't say one way or the other, but I can tell you what, it is biology. And these little holes up here, I'm not sure if there's separate holes or there's just happens to be falling out in that one specific spot. But all of the things that I have found have blood vessels in them. And blood vessels, if they're the arterial blood vessels, they stay open and water flows through them. Veins, they shut right off. But the arterial ones are open and they bleed right out of the ends. All right, thank you for letting me use that Philippe Cloutier Master Philippe. All right, I told you that I know about the Baalbek stone. There they are. These are exactly identical. And when that breaks off, it breaks off flat as a pancake. They didn't even have to carve them. In between, there's a little slot in between each stone. And let me show you what Baalbek looks like. All right, this is some of the stones in Baalbek. See that between? That's what the ones I just showed you. You see this little stuff? That is that's that leucine-rich proteins. They call them slurpees, small leucine-rich proteins. Well, these would be gigantic leucine-rich proteins. But at the very end, they have a little bit of, well, here, hold on a second. Whoops. I know about this too. I know exactly what that is. Oh, man. Whoops. I gotta find where I was. Hold on a second. I know exactly what that is too. Now, we got so much to go over. It's just, whoever talks about this, nobody. What is this? You see all the outside pattern here? You see the width of this thing? I don't know how wide it is, but it's damn wide. And there's two big wheels, and this is like tank treads. And it was made to work in a wet environment, obviously. And it was cutting slabs of wet flesh, which were the giants that were there drying out after the flood. They used these and made walls out of them in the back. Those are those gigantic walls that fit together so perfectly because they were wet like putty. I've gone over this a million times, and not one single geologist or archaeologist or any of them want to discuss this kind of stuff because they can't address it and stay in their position of authority. And all I'm doing is asking for them to say, yeah, let's take a look at this. And the guy that steps up first is going to be a hero because 10 years, nobody, zero. Okay, my friends, here's another one. They say 17 most unusual, unreal rock formations. Well, let me show you what that rock formation is. It's Utah Arches. I believe it's Utah Arches National Park. That is a tendon enthesis strap attached to a ball which was anchored to flesh that was this high up. There was another one right here that anchored down to that ball, and then there's balls all over the place. And this had eroded away. Originally, this attached to a strap, and I'll show you what the straps look like. All right, there's that tendon ball right there. It's pulled out from the mat, which was down here. That's an injury. It's supposed to stay down there. That's the strap, and the arches goes here. This has eroded the flesh. In this case, they took and broke these little stubs off of here and made walls out of these tendon mats down in Peru and all those places. See, what are these bumps sticking out? If you look down the center of them, you can see the vascularness of them. Okay, I showed you the biological sample of how those tendon balls are attached with these straps. And this is an example of what they did. They cut them while they were still wet and just slapped them together. And not, they did it very nicely, highly, extremely accomplished. This, for all the world, looks to me like they were testing the different methods of leaving. See the bumps, how they have the little, that's biological on these bumps. And that's what they had, a whole batch of them, as I showed you the actual autopsy pictures. Now, they scraped some off, they left some. These are natural. They attach just in little blocks like that. And that gives it the ability to stretch and do all these kind of things. But it looks to me like this was a test wall. Okay, I know I showed you the tendons with the tire tracks running up and the slabs cut off. I have a bunch of more. I have so much stuff I could go on forever. But this shows that, you see that? That is part of a bone. The bones, on the outside of the bone, you know, they had the flesh and they had the tendons, and if they cut them just the right way, they would just end up with the tendinous material. And there's little tags at the bottom, but sometimes they would get them in extremely bloody condition. You see that? That's where they built the walls in the back. This is where they cut the slabs. This is a tendon. This is bloody synovial sheath. Here's another area. This is tendinous material. I'm going to show you in a second. And it's very, very tough. It's primarily CaCO3, calcium carbonates. They built the walls back here. All right, these are like mountains and so forth, literally. And these are those tendons that run down and just sort of shape down. And these are the fibers. There's abrupt transitions here and there, and I believe that's one of them, or they might just have bent it that way. But there are those abrupt transitions. I believe I showed you that. You see that? That's another abrupt transition. Now, this just happened to be something they call Nisus pegmatite. But that's that tendon locked into the glue, and then it starts into the muscle fibers that run up above. And it depends on the conditions that it petrified in, what the water solution was, how long it lasted, if it was in mud, what the mineral content of the mud was it near an organ, bile, salts, acids, chemistry of some sort that would affect it. And this looks like it was in very clear-ish water with an abundant source of transition metals, which are the things that transition. But usually they come and they go, but when you die, they come and they stay. And that's what happened here. And that's what happens with agate and opal. It's a very similar process. Okay, I'm going to leave it at this. I've proven everything I need to prove. It's time for somebody to step up and say, all right, let's look into this. This is an abrupt transition, obviously. This is the gluey part, obviously. The muscle ran above, I'm just going to say obviously. The tendinous, durable material is in the ground, because otherwise you're going to see these tendons. The tendons are the strong part. It could go either way, but I'm sure that the tendons are in the ground and the muscle is up this way. Tyson Carlson just got a drone. He's been working this area and he's finding membranes, bilipid membranes. It means they have a membrane on this side, a membrane on that side, and in between they have what they call a fatty solution, hydrophilic, hydrophobic, and channels and all this business, and he's got them and showing them. Well, let me show you that, and I'm going to leave it at that, because we got so much work to do that I could go on for weeks, and we need to get a forum going somewhere where we can interact and be able to do question and answers on a big scale, because I can't do this onesies and twosies. I'm just getting worn out, my friends, I'm telling you. Okay, my friends, next video we're going to get into all the different types of tendinenthesis and how they anchor, but I've shown enough today to prove my point. I'm pretty convinced that anybody that paid attention can't really come up with any definitive answer to say that I didn't prove my point. Now, as far as having life being this gigantic, it just shows that the ancient texts are nothing to be scoffed at anymore. We need to start over again and let's just start to think. Just pay attention. Let's walk in truth. All right? Well, I can't walk around in circles and pretend that this isn't true. It's true. And it can be proven now. I mean, we have all the tools to prove this. I mean, I don't really have to go any further with this, but I can't get any traction, anybody paying attention. And this stuff is out in space. It's coming through space. I have stuff right here, right now, that came from space, has blood in it. They always ask, whoa, what about space? Well, they don't want answers. That's the key. They do not want answers. If you want answers, here's who you should contact. Moi. It's a little French for you there. Roger at mudfossils.com. If you are in the realm that can get this noticed, like Joe Rogan or some academic that can present this forward, because it's going to be presented sooner or later, and the one that does it is going to be recognized as the one that that is a truthful, honest, academic host of a radio show, whatever it is. I can't find anybody that takes any interest whatsoever in 10 years. And I have DNA tests, I have CAT scans, I have specimens, I have all the things I've just shown you. So it's not like I'm just making things up and coming up with guesses that are insane. It is insane, yeah, absolutely. It's the most, nobody would ever consider this in their whole lives. It's just that it absolutely, the circumstances that led me to this, I'm going to leave it at that. And it's up to you to find truth in this or not. I can't do it anymore.